we just started on collections on that day, right? So yeah, we just discussed on collection framework, like how it evolved and all, like what exactly is a problem with defining different variables, right? So in spite of different variables, so what are the different issues we have, like maintenance and all. So how arrays came up and how we can use arrays in different way, and what is the memory allocation for arrays, as we have discussed on that day, right? That if you define any static size for this array, and if you want to grow this program for multiple situations, right, again you have to change your program, which is arrays cannot be grown dynamically. But yes, you can also use something called dynamic initialization or instantiation of array, but again you have to store all the values at somewhere, again get back all these things into this array, right? Which is again you're iterating through something which is not needed here, right? So in that situation we got something called collections, right? So that is where we got something called connections, which is completely dynamic. In the memory allocation is complete dynamic, right? So as much as you add your items, so with respect to that, your collection memory size will grow, right? If you are adding just 2 items in there, right, 2 integers as such, then the collection will be of maximum of 8 bytes. It won't grow beyond that, right? I'm sorry, 8 bytes, right? So in the same way, if you add some string, so based on the number of characters you are actually appending, the size will be defined for collection. In the same way, if you delete something, automatically that part of value will be deleted. Same way, the memory being allocated for that value will be removed from the array stack, right? So as such that and also you can also delete something called the values in between the values what you have in an array stack. Like here, if you can see this array, right, if you have few values here, right, let's say you have a stack like this. You have a stack where you have some values like 23 or some 45 and 12, 78 or 35 and right, like this, right? So where think about this an array stack, right, normal array stack, where if you delete any of your index values, right, if you are deleting something called array of this 12, this index one, which means this space will be empty. This space will be empty, and until you populate anything in here, or if you don't substitute, or if you keep this empty, this will stay as it is, and your array will be growing, but this will not be replaced with with any other value unless you do this. But in collections it is not the case. In collections, how it happens is, if you delete anything from in between your array stack, your items will be automatically arranged back, right, arranged back to that space. It will be filled up by the next items. That is how it works. And if you want to add anything, let us say you have a complete array stack where you want to add something like 12 in between, right? So what happens is your next items will be arranged to the next index automatically. So that is how the dynamic arrangement of our collections is done. It is same case with all the collection items. We'll see what are the different collections we have and all. We just touching upon what exactly it is being here, right? So that is how it works. But anyways, internally everything, all the collection items will work as an array stack, right? All the collection items will act as an array stack, but they have got different behaviors in each and every collection item. We'll see what are the different behaviors we have in them, so when we actually come to each and every item of a collection, right? Yeah. So let's get into the actual business, which is collections, right? Yeah. So under collection, so basically collections is a complete interface. All the classes whatever we have, the entities in here is nothing but your interfaces, right? So under collections you have a main division.
Hello?
Yeah, hello. Hello,
I can't hear anything. Hello?
can you guys hear me?
Hello?
Hello, hi Ron. Hi Ujjwala.
Yeah, I can't hear anything.
You can't hear.
Okay, so it's a problem from.
Okay, so let us understand what is a list first. So as we were discussing, collections can save any object in it. Any object as such, it can save an integer or a string or any object, or it can save all the duplicate values. It doesn't matter what data it is. So it will be used as a single entity to save multiple objects in it. Now, what is the difference between a list and a set is? These two are the main things. A list is something which will save any object into it, but set is something which will save only unique objects into it. So the duplicate values are not allowed in set. So that is the main difference between a list and a set. Both works in the same way. Only thing is the data storage or the data elements which is being accepted by these two are different. Set will save only unique values, unique objects as such. It can be anything. If you are providing something called hello some word, like you are just appending it to the set, right? And if you append the same thing again, it will not allow, but it may allow something called hello word as such, because these two are something which are quite different objects, right? If you actually go into the ASCII values of complete, it will be mainly different. So this won't be a unique objects, but sets will save only unique objects, and where lists can save all the unique and every object as such, it can be saved in this list, right? That's the main difference. And what is a queue? We'll understand what is a queue once we understand what is a list. Then it will be very easy for you to actually understand queues and maps very easily, right? First understand what is a list and how actually we can define what are the different items we have in list and what are they, right? And across these collections, right, complete collections of collections and maps, all these items, we have a sub flavors called, we have some sub flavors which we have to discuss now itself, right? Sub flavors, right, which is any collection item can be of these four. The first one is it can be ordered, or it can be sorted, or in negative manner this can be unordered, or it can be unsorted. Now, so these are the things which all these collection items work on. So ordered is nothing but the values, whatever you save in particular way, in certain pattern, right? So those things will be retained by some of the collection items. And sorted is nothing but whatever value or object you enter into the collection item will be automatically sorted. If you enter 32 and 12, right, automatically the 12 will be the first item and 32 will be the second item. It will be automatically sorted. Yeah. Unordered in the sense there will be no guarantee that whatever order you are maintaining to actually append your item may not be in ordered manner. You entered 32, 45, 12 and 78, right? It may be jumbled. It may be like 32, after 32 it becomes 78, right? Only thing is your data will be persistent. That's the only guarantee that you have in unordered collection. But in ordered collection, whatever you enter, it will be all the sequence will be maintained or persistent. That is nothing but an ordered and unordered. And unsorted is something which is where it will not be ordered first, there won't be any guarantee of order, and there won't be any guarantee of sorting. Anyways, whatever values you enter, only all the objects will be persistent in unordered way or an unsorted way. That is nothing but your sub flavors of this. And each and every item of a collection may come under any one of them, right? So that is what it is, or any one of them or a combination of them. It can be ordered and sorted. Yes, even that may come. or it can be only one, right? It all depends on, because we are not the one who will be deciding this, because it is all the APIs are already been provided in this manner, right? And based on our requirement, so we'll be going on with any one of the collection item to use to actually meet our requirement, right? So that is how it goes. Now, so under list you have we have some direct classes, which is the first class is array list. So mostly used one, array list. And then you have linked list, you have a vector, and you have a stack. So these are list items which you have under collections, right? We'll be seeing each and every collection item whatever we have in detail. And under set you have hash set, and you have sorted set, or let us say linked set, linked hash set, right? And we have something called sorted set. So under sorted set you have something called tree set. We'll see how we can build a tree set, and how the internal sorting is be done. So how this is using a tree sorting internally, right? As we have learned in our graduation, right? So we have seen different type of sortings, right? So we'll see the same sorting, tree sorting is being applied here. Anyways, we'll see how it is being applied when we come to sets called sort set, right? And then in queues uses the same list I said, which is a linked list, because it may use a linked list because it needs something called queue. Is I hope we know that queue is something which maintains the order first, and second things, first come is first serve. The same thing happens here. The first basic rule of queue is it should maintain an order, right? Whoever comes into queue first, he should be in the first line, he should be in the first among all, and whoever enters as a 8th guy, he should be at the 8th place permanently, until unless the first person is served and he is going out, right? All the items should not move on. That's a queue, and we'll see what are the different things we have in this, right? Yeah. And then under maps you have hash map, right? You have hash table, and you have linked hash map, and you have again sorted map, so under which you have something called tree map, okay? So these are the complete division of complete collection items we have again. So here you can see there are the names are a bit same as such. You can see here, you see here hash and linked and sorted. You can see hash, linked and sorted. So once you understand this items, right, at one place, you will understand the complete picture of collections, I'm sure. Once you understand array list and linked list, you will get a complete picture of what exactly is a linked or hash and maps, right? I'm sure of that. Yeah. So we'll learn each and every item as such, but before that, let us see what is maps first, right? So I hope we have understood what is collections, right? Collection is a set of items where list will save all the items, set will save only unique objects, and queue will save all the items but in a ordered manner, right? This very important thing is it is ordered. It should be ordered, right? Yeah. And now maps. So what is a map? A map is nothing but to be more specific, map is like an lookup table, right? Map is mainly used as a cache item where you can save something called a key and a value. So all these things have only one item at a time, but here you can save 2 items in an array item. So how it will be saved is, it will be like an array item. So we know that, so everything will be saved in a stack manner, but in this stack, so how the data will be there is, it will be there like key and a value. It should be separated by a comma. Let us say, take an example of key is a student ID and student name, let us say. In the same way, we have second item will be student ID again, and let us say student name. Oops. Right, and student ID again, and some ADT, some student name, and it goes, right, and goes on as such. So here you can see it will be like a table, lookup table. So to draw in a table manner, it will be like key and a value, where you have this as a table, where you have a key, again you have a value, you have a key, you have a value. So as such, this you have a key like 3 and you have a value, right? So this is something which will be saved in this manner, but this will be each and every item, combination of this will be one array item, and second will be the second array item, right, separated by something. But anyways, for reading maps, it's very easy how to read and populate them. We'll see how. Now here basically the only condition in maps is you can save any of the values, you can save duplicate again, but only thing is you should always have something called a unique key, right? If I try to add something called, let us say I have a map, if I try to add 2 with something called some TV, some DVD, some other student name, so what happens to this map is it will check first whether this key is there or not. You can see that this key is already there. Then what it will do is it will just replace the value with this, but it will not allow any duplicate values, same as set. Okay, the same behavior is in set, which is, let us say in set you have again the same array, which is 32, 78, 45 and all. Now let us say you are trying to add your 12 again to this set. So what happens is it will check whether the same object is there or not. If it is there, maybe what it will do is it will replace this with this, that's it, but the duplicate values will never be saved. So that is how your set works, that is how your map works. But map is something which is a combination of key and value. Now how it works is, let us say you want, now you can see here, let us say you want a 670, let us say you are actually saving 100 students, let us say, and if you want to get some 67th ID, then you have all the IDs being saved here, right, which is a key. You can get the ID and directly you can get the name of a student, which is this, which will be a value. That is how your map work. All the map items, the basic rule of all the map items is the same. There is no difference in any of the items, right? And all your sorted set items is the same, all your list items is the same, right? So that is what we have on very brief manner, what exactly are the collection items, what exactly are the maps we have and all, right? And what are the sub flavors? Again, these sub flavors will be applied for all maps, for all collection items, right? So a map can be, again, a map can be, if you are actually, so how it is applied here is, how a ordered, sorted or unordered is applied is, it is all depends on a key. If you want to see whatever item you add, like I added first student, second student, third student, right? I want to maintain a ordered way, you will be using one of this item. If you don't want an order, if you want an unordered, right, your order is not an mandatory one, but only thing is you want to save the key and a value, like student ID and name, that's fine. You can go for some of these. Yeah, you have all the possibilities. And if you want to sort, so how it is sorted is, it is sorted based on your key and not the value, right? Again, key can be anything. I just gave number, it can be anything. It can be, again, something, key can be anything. It can be a string, it can be it can be anything, right? A key can be anything, a value can be. So key, until unless your program understands that, okay, this is a key and this is a value, it holds good, right? Again, in the same way, if you try to add a key, again the same thing, I key, and what it will do is it will be replacing the old one again, right? So that is how it works internally, and we'll see how exactly they work. Now let us understand what is an array list first, right? So we'll see how we can actually create an array list, and right, we'll see how it works. So let me create a project. let us say collections. So here let me take one package. Yeah, so we'll create a class CLS calls. Okay, close this. Okay, so here yeah, so it is a direct class asset. You can see all your collection items will come under something called java.util package. Each and every item, all your array list, linked list, whatever it can be, right, comes under util package. Now here the basic syntax of array list, you see the what is the basic syntax of array list. Array list here you can define in two ways. The first way is it gives something called what type of items you want to save. Let us say I am giving something called object here, right? Object, let us say I am taking a value of obj is equal to new. You have to again instantiate your array list. So this is how you actually maintain or define your arrays. Again, all the three rules which we have learned in our arrays, which is declare array, right, construct array, and then initialize array. The same thing applies good here. So here the declaration part is this: we are declaring an array of object type, right, which can actually accept any object as such, and the variable is obj, and then we have to construct an array. Construction is nothing but an instantiation of array. Now here you can see that we are instantiating an array. Now obviously this will be pointing to an array class which can accept all the objects. Like now next point is how we can add, how we can do different operations on this, right? The first thing is how we can actually add an item to this. So again this is again the same. Let me just take it as obj dot. Here you have everything as a internal method. Actually click on add. Now you can actually add the items. Let us say hi obj dot add. So whatever you add will be added in a stack manner. Again internally it will all everything will be arranged in a array form, right? You can give 20, right, obj dot add, or you can mention some hash maybe, right? Even your hash you should be defining it in some way. Let us say text, and then you can have obj dot add of a number can be in certain manner. Yeah, so this is how you add items at different objects, different type of objects into a collection item. Now we are checking out something called array list. So now this is how you actually define them. Now so we have done something called declaration, initialization, construction and initialization. So now again whatever you have added again will be added in a stack in a array manner. Same, the 0th index item will be high, and first will be 20, third will be hash and all. Now let us just write a small loop to actually get that out. Now here, now as we have a length of an array, right, so you have in collections you have something called size. All the collection items, see, this feature of add or size will be same for all the collection items. So whenever I say all the collection items, for all these it's the same thing. There is no difference in any of the internal methods whatever we are using in here, but the only thing is the behavior, like internal arrangement, will be different. So that will be discussing, right? Now here how to get the item is here. First let us get how to actually retrieve the item. It is like this: obj dot, you have a function called get, where you have to mention which index value you want to get. Now let us say I want to get the first index value, right? Let me just see. This is err of e dot get message. Keep it here. Now let me run this program once. you can see 20, which is this one. Now unless you instantiate this, right? Let us say we have not instantiated this, right? If you don't instantiate these values, right, again, which is null, let us say, yeah, you're not instantiating and you're directly trying to add the values, again, see what happens. It will throw you null error again. This behaves as same as your array, right? This collection item should be instantiated, right, which is this. Now in the same way, let us say if I want to get something which is not there, like let us say 8th item, right? You will see that I have only few things in here, which is I have only 4 values, up till 3 I have populated. Now here what happens when I try to get something which is not there? You can see direct index out of nothing, right? It internally works as an array, I said, right? So here the main size of this item is 4, but you are trying to get something which is not there. That's why it doesn't give anything, right? It throws an error again, right? Let me write here exception so that you can understand that you are getting exception, right? You can see it's an exception, right? So that's how again it follows. And here to iterate it again here we are giving the index, right? You can give the same value here, which is, let me assist out of obj dot get of your index I. Anyways, your index starts from 0 even in array list, right? We are touching upon till your the maximum size of array. When I run this, you can see all the items picked. And again, how we can actually do something called for each here. You can also apply for each here, which is for each, again it will iterate through object. Now how we can use this is, as we have seen before, if you define any int array, right, we used to say for each int I in that set. The same way here, what we can do is for each object. Why? Because this array list is capable of saving any object. So that's why we have to take in for each, you have to take all the objects from something called obj. This obj is nothing but a variable of array list. Now again, as we have learned before, it will give direct item to you. Let us say I'm just taking an variable as item, right? So here it will take the complete item, right? So let me put some thing in here, right? So what happens here is, if I run this up, right, you'll see the complete set items. So what happens here is, anyways, both works in the same way, but here what you are doing is you are just touching the index first and then getting the value, which means you are actually going to the memory location and getting, but here we are directly getting the item. That's a main difference. And obviously for each will be anytime for each will be much faster than your indexing, getting the values through index, right? That is how it works. Now, so here you have something called obj dot to remove item. You have a remove. You can give an index here, right? Let us say I'm giving an index of 0. So it will remove the item, and what it does is, I'm removing the 0th index, right? What happens here is, the items will be, I said, will be rearranged back. Your 20 item will become 0, hash will become 1 and all. Let me run this. You can see the 0th item became 20 because we removed some item here. That's how it became some 20 here, and again even in for each it became the same. Now let us say I'm removing some in between value. Let us say I'll remove this hash, which is 0, 1, 2, right? And I'll run. You can see the 1, 2, 3, 4 will become a second value, right? That is how it rearranges everything. Now this is how your array list works. Now let us see how the pattern works in between. What is the pattern, how it is working inside, and what is the disadvantage of using array list. Now whenever you create an array list and whenever you add, anyways we'll be seeing more internal methods of different lists when we move on to different items, right? First let us see what is the main disadvantage or how internally works when we actually add something, right? And you also have something called obj dot add, right? Here you can see you can mention an index. Let us say I want to add a second index, right? And the value is some second, let us say, right? An item, so I don't want to remove here. So here what happens is what I'm doing, I have a 4 values here, so this is my second indexed one. But what I'm doing, I'm adding a value, different object at second index. See what happens here, it will add the value at second, and each and every item will be moved to the next. Each and every value will be moved. So this is the 2 behaviors which you have, and pertaining to this, let us understand how it works. Now here let us say we have array again, right? So now internally array list will be saved in this manner, which is a stack again, right? So now here, so let us say you have values, let me just copy this again so that we don't have to waste time here. Okay, let me just take this. Yep. So here first let us see, if I am trying to add anything at the end, right, it will be added at the end, right, like this. Now this is much faster because it takes the last memory location and it will add up. Now let us say if I am adding something or removing something from here, what happens? Let us say as such I have, right, as these items I have some 1000 items, let's say, right? Because your collection can hold any, that's why collection is a heavier cache memory, where it can save any number of objects, but all the objects will be persisted until unless your application is killed, nothing will be lost, right? Now here let us say I want to delete my item which is 45, right? Now what happens if I delete something in here? What happens is each and every item after 45 will be rearranged. You can see that I am trying to delete something which is at start, right, which is at start here, at third index or second index here, right? Now you can imagine how much time it will take to rearrange all the 1000 items. The third item will become second, fourth will become third, fifth will become fourth again, right? Everything will be rearranged, which means an adding of something or removal something which is at start will actually hit your performance. And in the same way, let us say I'm adding something here which is in the second index, I'm adding some 0 here. What happens again? All the 1000 items will move a step next, which is a fourth will become fifth, fifth will become sixth and all, because I have to embed one item in between. So that is a main disadvantage of an array list, right? Whatever happens in between or the later, right, all the items will be rearranged to the next or the previous, right? So that is how your array list internally works. And again, if you have if you have many items and if you do some operation in between, again your performance will be hit. Now this was the main problem with array list. Now to solve this problem, we have something called linked list. We'll see how linked list works. Now here you can see there won't be any change of anything in here. You'll see the same thing. Let me just change it to linked list. Even the linked list declaration is same. You have something called linked list, right? Again the declaration part is same. You can say object, right? Let me take it at obj again is equal to new linked list, right? Let me comment it out. Whatever methods we have written for adding, for maybe removing, for removing, right, for getting things, everything will be same. Let me run this. You will see the same error again, right, because we are trying to do something. Let me comment it out first and let me run this again. You will see the second item will be removed, but I am adding one more second. You can see second here. I'll comment this, remove one, and run this up again. You will see the same behavior, right? Your hash will be moved and second will be added. Everything will be same in link as such, but only thing is the internal way of arrangement is different. We'll see what is that. Now here we have seen something this, right? Again your linked list will be arranged in the same manner, but it uses something called double linked list. I hope you know what is double linked list. So each and every item will be connected in this way, right? Which is this, right? So each and every item will be linked with a bond, which is like this. You have all the bonds here and all. Let us say you have this much, and you have some 1000 items, let us say, right? Same way you will be having this bond here, now what exactly it is now. So how the items will be arranged in here is, the first item will have this node. I can say node, I can take an element as node. Each and every node will have 3 different memory locations. We'll see what are they. Okay, we'll see it in graphical manner so that we'll understand much better linked list, because it is very important to know linked list. Now here, so we were talking about linked list, right? A single node will be having 3 different lists. The 3 different memory locations. The middle memory location is to save a value. Let us say we are saving 32 here, right? And I said each and every node will be like this. Let me take 3 nodes. Again your value will be here, which is nothing but 52, let us say, right? And let us say 12. These are my actual values. Now here what happens is, this memory location is to save this memory, which means this memory will be saved here, and the same way the left memory of next node is to save this memory item. The location of 52 will be saved in 32's right slot, and the same way location of 32 or memory location of 32 will be saved in the left location of next node. This is how each and every node will be bonded. Again in the same way, 12th location will be saved here, and the same 52th location will be saved here, right? So this is how your linked list items will be actually arranged, right? In the same way, if you have again different nodes again, right? Let us say, let me just block it here. Let us say you have one more, which is, let us say 47. What happens? This memory location will be saved here, and the same way this memory location will be obviously saved here. So that is how each and every node is being tagged. Now this node is again, let us say 0th index, 1st index, 2nd and 3rd. The arrangement will be same, it will be indexed, but each node, now here whenever you come to linked list, right, it will be a node again. The main, you should not call it as an item, it is a node where you have 2 different memory locations to save the memory address of the immediate one. Now here the node which doesn't contain the left memory allocation or the left slot is called as a first node, and the node which doesn't have a right memory allocation free is called as a last node, right? So this is something which is data structures. All the nodes will be saved in a data structure manner. Now why I am explaining more about this is, now here let us say I am removing this item. I want to remove this item. Now what happens? Even if you have 1000 items, right, again this will be saving something else, right? Even if you have 1000 items, only 3 nodes will get affected. This node, this node and this node. Practically only 2 nodes, which is 0th and 2nd. What happens here is, whenever I want to remove this, which means I am actually removing this bond, which is the 32 will be actually saved here, and 12th item will be saved here. That's it. And this node will be removed. Okay.
So I have a question.
Sure, Archana.
So what is the use of saving it 2 times? I didn't understand the purpose behind it.
I'm sorry. Where are we saving 2 times here?
means the 32 number we are saving in 52
Mhm.
is first block,
Mhm.
and
Mhm.
52 we are saving 52
No,
last
no, no.
block.
Actually, yep, yeah, I understood your question. Okay, we'll take
And
that.
even the 52 we are saving it in another memory's first block.
Yes, yes. I'll make you understand that. Yeah, sure, I got it. But actually, there is only one thing being saved here. I understood your question. It is like this. See, this 32 was the first item, right? First item. I'm not taking index. I'm taking a direct position of that. Okay. My 32 was the first item. Now, in linked list, what happens is the second item will be saved in first item. This is second item. So how the relation is being made is the 32 address will be saved in 52, right? And 52's address will be saved in 32. Now, why do we need this? Now, whenever you come to 52 item, right? Let us say you are in 52. Now, you want to know what is the previous item in 52, right? What is the previous item for this? Now, if you want to get the previous item, obviously what we'll do, you'll go to the slot and whatever memory will be saved. Now here only one memory is saved. Don't get this arrow directly. I'm just showing the arrow, like the memory will be like this. It is 32, 3 slots again, 32.
So actually in memory it happens like there will be 3 slots per
node. 3 slots for each node, right? And let us say what I'll do is, see, let us say the memory of 32 is X, right? And memory of 52 is Y. Let us say this Y will be saved here and X will be saved here. That's it. Don't worry about the arrow marks. This is how it saves. Okay, because
that's what my question is. So if suppose there is one more item after 52, the 52 is going to get saved in another block, right? So what is the purpose of saving it 3 times?
I'll tell you that. So let us say 12 is there. You said, let us say this memory location is nothing but Z, let us say, right? So Z will be saved here and Y will be saved here. Now, so see here, how do we know that first item is 32? Because we don't have previous item, right? The first question, you understood this first thing?
Okay.
How do we decide that a node is first node is if this node doesn't have any previous memory location or previous item, which means that is the first thing. Am I right? Yeah.
Okay.
Now, how do we know the next item of this 32? You will go to the next slot, right? And you have a memory address of a next item, right? Don't as of now, just think about I have only one node, which is 32. Right? Forget about these two. I have only one node which is 32. Now, pertaining to this 32, I don't have any previous node because I don't have any memory being saved at the left side. Now, at the right side, I am checking whether there is a next node or not. Now, here I can see that there is in my right memory location, I have Y being saved. Y means this is an address of some node. This can be second node or anything. But as it is saved here, which means my Y is nothing but this 52. Am I right? First thing. Now forget about whether I have X or not. So now this 52 means my 32's next value is 52, which means next is this, right? Now come to second node 50, which is 52. Now in this 52, first thing is I want to check whether when I am at 52, I want to check whether there is some node at before or not. Now this memory address is X and I am saving X here, which means 52's previous value is my 32. You understood this first? Forget about the third node here. I have X here and I have Y here, which means my second item pertaining to 32 is 52, and with respect to 52, my previous item is my 32. This location will give you the item of next one, and the left location will give you the location of the previous one. Now let's extend this. Now we are in second node, which is 52. In this 52, we want to check whether there is some other nodes, right? Now we have one more node whose memory location is Z, right? Now this Z we are storing in here. Now this means, yes, after 52 we have one more node called Z, whose value is 12, right? And in this 12, when you come to this node, you have to understand, okay, whether there is node previous to this. The previous node is 52, that's why we are saving Y here. Now to answer your question, why we are saving 2 times is, here these 2 times is not same. The first time we are saving it as a next node, which is a right side here, but here we are saving as a left side, which is this node's left node is 52 and this node's right node is 52. You understood this confusion here?
Yeah.
Yeah, a sort of
Yeah, I
confusion.
will go through some.
Okay, so here Ujjwala, it is same thing. You see, when you are going through array, right? First thing, I'll let us go in a very low level. Let us say you have array of 3 items. Okay, let me just get back to our here, which is this. You understand this first. Let us say you have an array of items, right? Array of items, which is 0 item, first item, second item, third item, fourth item, fifth item, right? Yeah. Now when we come to array, right, how do we know that this is first item, second item, third item? Because it will be saved as an index, right? Because this will be 0, this will be, right? Am I right? This will be 1 and all. Now, yeah, right. This will be your 1 and so on. Now here, how your items will be saved here is, this will be 0. Anyways, this will be 0. Fine. This will be 0. Now how do we know the first item? Now you will be saying that this will be first item, but how do we know this as a first item? Is because we are saving the memory of 78, or we are linking the 78 with 32 and 32 with 78, right? That is why we say this is the first item, this is the second item, because there is double bond here. The one bond is 32 is being saved in 78 and 78 address is being saved in 32. That is nothing but your double linked list, double bond.
Okay.
In the
So my
same,
question is,
yeah.
it is same in the array also, right? Because in array also we have a method called as next. When we call next array.next, it gives a next value.
No, this is stack, Ujjwala. So your array will be saved as a stack. So what is stack? You understand stack?
Yeah.
Yeah,
I
you
know.
understand stack, right? It will be in a stack manner. It will be in a stack manner, but this will not be in a stack manner. No.
So this will be in array.
Yeah. See, here each and every item will be in a stack, right? But here only 2 items, 32 and 78, have got only relation. 32 doesn't have to do anything with the remaining items. No. 32 will have business only with 78, but 78 have got business with 32 and 45, right? And 45 have got business with 78 and 12. As this is a linking with each other, that's why it is forming a linked list. A complete list will be formed, because if you talk about 78, right? 78 previous one is 32 and 78 next is 45. Am I right?
Yeah.
When you come
Got
to
it,
45, 45's previous is 78 and 45's next is 12. Now here, when I am saying previous, right, 45's previous is 78. How we are saying that? Because we are saving the left memory of 45 is nothing but 78's memory, and the right memory of 45 is being nothing but your 12's memory. Am I right? In the same way, when you come back to 78, how we say that 32 is my left or previous one? Because it will be having 3 slots, I said, right? It will be having 3 slots. The previous slot is nothing but 32's address, right? And here it will be 45's address, and in 45 again 3 slots, which is 78's address, right? And here 12's address, right? So here you can see in 45 I am saving 78, but as a previous address. Am I right? And here 32 will have only 1. Anyways, this will have 2, but we have only one thing called 78's address. Why do you have at right side? Why do you have? Because 32's next is 78, but here 45's previous is 78. This is how it will be saved. Okay. just go through this video again and again. I understand that, once you would have understood something called double linked list in graduation, because you will be getting these, right? C and DS, it will be coming on C++ data structures, right? So this arrangement will be done in something called double linked list, right? One link is this and another link is 78 address is saved here and 32's address is saved here, which is a previous and a next, right? Fine. Yeah, so that is how it is actually being saved, right? Just go through this again, you will understand linked list. Yeah. So why it is making this bond is, now you will understand why actually in linked list we are using something called double links bond. Now let us say we have 1000 items, right? Now let us say I want to remove this 12, right? If I want to remove this 12, which means, what does it mean is, now when I remove this 12, what will be the next of 45? It will be 35, right? If I'm not wrong, right? Which means I am trying to remove this 12, right? If I remove this 12, which means 45's next will be 35 and 35's previous will be 45, which means double bond will be like this. Am I right? Now how many nodes you are touching? You are touching only 2 nodes. What you are doing is, whenever you want to delete in between value 12 here, right? Which means you are just deleting, you are just pointing 45's next to be 35 and 35's previous to be 45. That's it. Which means this 12 has become connectionless and it will be removed. Now how many nodes you are touching? Only 2 nodes, which means even if you have 1000 nodes, doesn't matter at all. Only 2 nodes are being touched for removing something. In the same way, if you want to add something, now the game comes here again. Let us say I want to add some 709 in between my 45 and 35. So what happens here? Now here, whenever we want to do that, right, what happens here is like this. Now initially my 45's next was 35, but what I am doing, I want to insert a separate node in between 45 and 35, which means my 45's next will become my 709 and my 79's next will become 35. In the same way, 35's previous will become your 709, right, which is this. And in the same way, your 709's previous will become 45, which is this, right? Now this node is a legal node when compared to 45 and 35, because 45's next is 709, 70's previous is 45. In the same way, 709's next became 35 and 35's previous became 709. Now this node is completely into this, right? So that is why we added. Now even for adding, how many nodes we touched? We touched only 45 and 35, 2 nodes, and our node became the legal node of this stream. That is how we add and remove. Now you can see the difference in array list and linked list. Linked list, you will be touching only 2 items to add or remove. That is how, even if you have 1000 or any number of items, the arrangement will be very fast here, right? So that is how your linked list works. Fine. Just go through this video again, but see, whatever I have explained here, right, whatever I have explained here will be done internally. You don't have to do something called save memory here or there. Linked list will do everything for you. What you have to do is, you have to follow something called linked list, and you have to understand 2 things. One is add, right, remove, or something called add at, which is index. Whatever we are doing here, linked list obj add at second, which means you are trying to add at second index. Am I right? So that is how it works. Fine. Yeah, I can understand if you don't have an idea of data structures, right? This will be somewhat, just go through this video again and again, and I'm sure you'll understand this. Fine, guys.
Srinath, this is Purush.
Yeah, Purush.
I understand linked list. The previous one is array list. So how does that find the next say? I mean, we have in the example, the second index is the value of 0. So how does it identify the next value of index? I mean, in other way, will array list will be able to find the next value and previous value?
I said this will be in a stack, right? It will be a stack, which means stack knows, right, the first what are the items being arranged. Let us say you have taken a pipe and you have filled with all the balls, right? You know what is the second ball, right? The same way your array will be there, but in linked list it is the story is completely different. So whenever you say 2, right, the actual data will be passed from first. It will be going from first and it will find what is the second item. Yeah.
Okay.
Yeah. Is that answers your question, Pushpata?
Yeah, I understand that.
Yeah, okay.
And the main reason for using linked list is to save memory when we are inserting or adding.
Exactly. And this is something which will maintain an order. Linked list is an ordered set. Whatever you enter, right, it will stay at the same place. But there is no guarantee that your array list will actually maintain order. No. I've shown you only few values, right? If you go and add some 100,000 values, right, again there is no guarantee that it will be in a same form. That is the main difference between array list and your linked list. That's why if you want to use a sequence where you want to maintain the same sequence of items, go for linked list. Fine, because each and every item is being bonded. Obviously there won't be any rearrangement in here. Fine. You may be getting one doubt here. I said arrays are saved in a stack manner, but in stack there won't be rearrangement. That will be your doubt, right? But internal to array list class, right, it will save only objects. It doesn't matter whether it will be shuffled. No, that is what it happens. Fine. But it will make sure that, see, it doesn't happen every time. It doesn't shuffle your thing every time. But sometimes, I don't know what logic is being inside, but we have seen something that when you are using array list, sometimes it will reverse your set. Sometimes, yeah, your last will be at first. Sometimes. So that's why if you want to maintain some sequence, go for linked list.
So we can't make the array list as ordered one?
You can't make an array list ordered one. No, never.
Oh, okay.
Yeah, because we can't change the behavior of an internal API, right? Right, Purush? Yeah.
No.
Yeah.
Yeah, I got it. I just wanted to know whether there is an option to do it.
No. We can't make it. Yeah.
Okay.
Fine.
Thanks, Srinath.
Yeah. So we'll wind up here, guys. So just go through this video again. I hope, maybe before coming to tomorrow's class, just get this linked list, right? Or if you want more, right, you can just browse on to the data structures double linked list. You'll be getting much better, maybe, right, much better explanation of that in videos, maybe YouTube, right? And you can just come back. Okay.
Srinath, did you still want to speak to me?
Yeah, I'll speak to you in Skype, Ron. Because other peoples may want to go, right? Let's speak in Skype.
Okay.
I'll call you.
Right? All right. Bye bye.
Bye bye, guys.